This is the next installation in the Number Theory and Computations module. And in this one, we'll be looking at probably one of my favorite topics, and that is fractions. So, what are fractions? Fractions are numbers that typically have two parts: the denominator or bottom number that describes the number of equal parts that is being divided into, and the numerator or top number, which describes the number of those parts we have. And both the numerator and the denominator have to be integers. And the best way to demonstrate this is with a diagram. So let's look at a pie, for example. Let's say we have a whole pie that is being divided into 4 equal parts, and we give 1, 2, 3 parts of the pie away. So I might eat a part of the pie, my friend Ali might eat another part of the pie, and another friend of mine, let's say Joe, might eat another part of the pie. This means that the fraction of the pie that is eaten by the three of us collectively is 3 over 4 or 3/4, where 3 is the numerator and it represents the 3 pieces of the pie that has been eaten, and 4 is the denominator and it represents the total number of pieces that the pie was divided into. So, next example. Let's say we have a pie that is being divided into 5 pieces. Now, let's say we have 2 of our friends take a part of the pie. This would mean that the fraction of the pie being eaten by the 2 friends collectively is 2/5, where 2 is the numerator and it's the number of pieces being eaten, and 5 is the denominator, and this is represents the number of parts that the pie was divided into. These fractions where the numerator is less than the denominator are called proper fractions. And if we take a look back above, we see that 2/5 is a proper fraction, and so is 3 over 4, right? Because the numerator is less than the denominator. So right about now, you probably would be asking, are there fractions where the numerator might be greater than the denominator? And the answer to that is yes. These fractions where the numerator is greater than the denominator are called improper fractions. For example, let's say we have 5 over 4 and we want a visual representation of this. So we draw up our little pie, and since our denominator is 4, we'd divide it into 4 parts. But we're taking 5 parts out of the pie. So let's shade 1, 2, 3, 4, okay? But we'd need another quarter, right? Another sector of the pie, but we don't have any more. So what we do is we actually would draw another pie, divide it into 4 again because our denominator is 4, so that we can get this 5th part. So this would be the visual representation of the fraction 5 over 4, where we have 4 out of 4 of one pie, right? Or one entire pie, you could say, and 1/4 or a quarter of another pie. So when we add these two together, we get 5/4 or 5 over 4. This brings me to my next point. Improper fractions can be written as mixed numbers. And a mixed number consists of a whole number and a proper fraction. So let's go back to the last example that we did. We saw that the improper fraction 5 over 4 from the diagram representation is 4 out of 4 plus 1/4. Well, 4 out of 4 is essentially the whole number 1, right? Which, if you think about it, should make sense because we're taking 4 parts out of an entire pie that is already being divided into 4 parts. So we're taking that whole pie. So 4 out of 4 is equal to 1, and we have 1/4 left back. So our improper fraction 5 over 4 can be written as a mixed number 1 and 1/4. And this makes sense, as we said before during the definition of fractions, that the denominator represents the number of equal parts being divided into. So essentially we have 5 being divided into 4 parts, or 5 divided by 4, which is 1, and we have a remainder of 1 left. So we'd write this as a fraction of 4, 1/4, since 1 divided by 4 isn't a whole number. So the improper fraction 5/4 would give 1 and 1/4 as a mixed number. Let's do a second example. 7/5. So this is an improper fraction because the numerator is greater than the denominator. So we can write all improper fractions as mixed numbers. Right away, how we think about this? Well, we know that we're dividing by 5 since our denominator is 5. And since we have 7 as a numerator, then 7 divided by 5 is 1. And there's a remainder of 2, which we write as 2/5. And we can check this graphically. We get, let's say, 2 pies, and we divide them equally into 5. But we want to take 7 parts in total. So we go 1, 2, 3, 4, 5 to complete this pie, and then 6 and 7 to end up with our 7 parts in total. So we have 5/5, which is just 1 for the first pie, and 2/5 of the second pie, which means our mixed number is, like we said, 1 and 2/5. Now, integers can be written as fractions. And this is something that you've probably already noticed. For example, let's take the integer 3. This integer 3 written as a fraction is 3/1. And we can show it graphically. It would simply mean we have 3 pies, each with 1 part since its denominator is 1. And this should make sense because we said before in the definition of fractions that the denominator represents a number of equal parts being divided into. So 3 divided into 1 part, or 3 divided by 1, is 3. Next example, the integer 5 written as a fraction is 5/1. By the same graphical representation, we'd have 5 singular pies, each with 1 part. Next example, -3. Well, this written as a fraction would be similar to +3 written as a fraction, which is just 3/1, as we said before, except we'd put the negative sign in front of the fraction. So -3 written as a fraction is -3/1. Last example, -5 written as a fraction is, as I'm sure you've guessed, -5/1. So any integer can be written as a fraction by simply writing the number with a denominator of 1. And remember to keep their respective signs. And again, this all makes sense because any number divided by 1 gives the same number, which we mentioned in our previous lecture when we talked about the multiplicative identity. Note well, any number that can be written as a fraction is called a rational number, denoted by Q. So now, what is the relationship between whole numbers, natural numbers, integers, and the rational numbers? If we recall from the previous lecture or previous lectures, we said that the set of natural numbers is a subset of the set of whole numbers, and that is a subset of the set of integers. And seeing as we just said that all integers can be written as fractions, and all fractions are rational numbers, then this would mean that the set of integers is a subset of the set of rational numbers, which makes the set of rational numbers the larger set of numbers that we've looked at so far. And this makes the end of the first lecture on fractions. In the next video, we'll be going into more details about fraction, doing things like simplifying fractions and performing operations on fractions. Remember, if you have any queries, then email us over at our website, linked in the description below. Give this video a like and remember to subscribe.